I am Dr. K.V. Girja, Associate Professor, Department of Science and Humanities. I am going to present, in continuation of the previous topic, complex matrices problems in the chapter vector spaces. Complex matrices problems. All the problems generally depending upon some properties of complex matrices, and usually the problems will depend upon the properties of the given topics. Here our property is every square matrix with complex elements can be uniquely expressed as the sum of Hermitian and skew Hermitian matrices. That is, A equal to half of A plus A power theta plus half of A minus A power theta, where half of A power A plus A power theta and half of A minus A power theta are Hermitian and skew Hermitian matrices of A. Example problem is express. They have given a problem as A, where A is the sum of Hermitian. We have to express it as sum of Hermitian and skew Hermitian matrices, where A is 2 plus 3i, 2, 5, minus 3 minus I, 7, 3 minus I, 3 minus 2i, I, and 2 plus I. Now, to the solution, given A equal to 2 plus 3i, 2, 5, minus 3 minus I, 7, 3 minus I, 2, 3 minus 2i, and 2 plus I. Now, here first we have to find out A power theta. For that, first we have to find out A dash, which is nothing but A transpose. In that, all the row will become column and column will become row. So, 2 plus 3i, then minus 3 minus I, 3 minus 2i, then second column will become second row, 2, 7i, then third column, 5, 3 minus I, 2 plus I will become third row. Next step is we have to find out A dash bar, which is nothing but A power theta. We have to find out the conjugate of all the complex elements. So 2 plus 3i become 2 minus 3i, minus 3 plus I. Minus 3 minus I became minus 3 plus I. 3 minus 2i became 3 plus 2i. Then 2, 7 plus I became minus I. 5 is there. 3 plus I became 3 minus I. Then 2 minus I. Next step, we have to find out A plus A power theta, which is 2 plus I, add these two, A and A power theta. When you are adding the numbers, it became the corresponding element should be added. So, 2 plus 3i, then add with 2 minus 3i, plus 3i minus 3i will get cancelled. We will get 4. The same way, 2 plus minus 3 plus I will become minus 1 plus I. 5 plus 3 plus 2i become 8 plus 2i. Then minus 3 minus I plus 2. Corresponding elements should be added. When you are adding that, we will get minus 1 minus I. Then 7 plus 7 is 14. Similarly, next element is 3 minus 2i. Then 3 minus 2i with 5 will give you 8 minus 2i. I plus 3 plus I will give 3 plus 2i. 2 plus I plus 2 minus I will give you 4. Next, we have to find out A minus A power theta. We have to subtract the corresponding elements. When we are subtracting the corresponding elements, the sign will get changed. Then we will get the answer as 6i. 2 minus of minus 3 minus I will give you 5 minus I. Then 2 minus 2i. All these corresponding elements we will get. Next, we have to find out 1 and 2. Take it as 2. And when you are adding this, we will get 2a equal to sum of A plus A power theta and A minus A power theta. when you are adding these two correspond the same way, we have to add the corresponding elements. So we will get 4 plus 6i, then minus 1 minus I, we will get all these elements. So, and also when we are adding this, we will get 2a equal to this. So a is equal to 1 by 2 of all the corresponding elements. We will get 4 will become 2, and by 2 all these elements we will get. Here this is the sum of Hermitian and skew Hermitian matrices. How come we know it is sum of Hermitian and this is skew Hermitian? There is a property for Hermitian as the diagonal elements will be necessarily real. By that property, we will decide it is Hermitian. Next is skew Hermitian. There is a property for skew Hermitian as the diagonal elements will be imaginary or zero. By that property, we will say this is skew Hermitian matrix. So A can be written as sum of Hermitian and skew Hermitian matrices. Next. In the same way, let us do the next problem as express the matrix 2, 4 plus I, 4i, 3i, 6 minus I, 2, 6, 4 minus 2i and 1 minus I is given. We have to write it as the sum of Hermitian and skew Hermitian matrices. That is, the same way, like a previous problem, we have to find out A dash, then A dash is nothing but the transpose, then A dash bar, which is A power theta. That is, A dash bar is nothing but for this A dash, we have to find out the complex conjugate, which is 2 plus 3i become minus 3i, 6 will be as it is, 4 plus I will become 4 minus I, 6 plus I will become 6 minus I will become 6 plus I, 4 plus 2i, minus 4i, 2, 1 plus I. This is A power theta. Next, find out A plus A power theta, like the previous problem. We will get 4, 4 minus 2i, 6 plus 4i, 4 plus 2i, 12, 6 plus 2i, and so on. Next, find out A minus A power theta, which is nothing but 0, 4 plus 2i. That is, we have to subtract the A power theta from A. We will get these elements 4i minus 6 minus 4 plus 4i, and so on. Now add this 1 and 2. We will get this A power theta will get cancelled. We will get 2a. 2a is equal to this plus this. Now a is nothing but take this 2 to the other side. So all the elements will be divided by 2. By dividing each and every element by 2, we will get 2, 2 minus I, 3 plus 2i, and so on. Even here also, we will get 0, 2 plus 2i, 2i minus 6, and so on. Now, this is the sum of Hermitian and skew Hermitian matrices. You see here, the diagonal elements of the first matrix is real number, and the diagonal elements of the second matrix are either 0 or complex number. Is it not? So the A can be written as the sum of Hermitian and skew Hermitian matrices. Next problem. Show that the matrix 2 plus I, 3, 2i by 3, 2i by 3, 2 minus I by 3 is unitary. What is the property of unitary matrix? That is, for the given matrix A, if A into A power theta is I, then the matrix is unitary. So we have to find out A power theta. A power theta is nothing but A dash bar. First, we have to find out A dash. A dash is nothing but the transpose of the given matrix. The same thing, 2 plus. In all the 4, in the given matrix, 3 is common in the denominator. So we can take 1 by 3 out. We will get 2 plus I, 2I, 2I and 2 minus I we will get. Now in this, A dash is this. Next is A dash bar. A dash bar is nothing but we have to change the sign of the imaginary element. So 2 plus I will become 2 minus I, plus 2I became minus 2I. This is minus 2I and 2 plus I. Now that is nothing but a power theta. Now a power theta into a we have to do. That is 1 by 3 into this into a. A is 1 by 3 into this. So we will get 1 by 9. When you multiply this one, 2 plus I into 2 minus I plus 2I into minus 2I will give you the total as 9. When you are multiplying first row with first column, we will get the total as 9. First row with second column will give you 0. Second row with first column will give you 0 and second row with second column will give you 9. In this, you take this 9 inside, we will get 1, 0, 0, 1. Now that is nothing but the identity matrix I. Now what we have got a power theta into A is equal to I. This shows that A is an unitary matrix. So to prove the given matrix is unitary, we have to prove the property A power theta into A equal to I. Here we have proved. So this is A is an unitary matrix. These are all the problems we have studied in complex matrices. Thank you.